Hello again, everybody. In this problem, what we're going to be doing is just analyzing a function. So given the graph of a function, we're going to try to figure out some different pieces of information about like the domain, the range, the intercepts, etc. So here's our function. The first thing we're going to do is find the domain. And the way that I like to think about this is we're going to take a vertical line like so, and we're going to drag it from the left-hand side to the right-hand side. And we're just going to make sure that at every x value, we do have a y value. So as we bring it across, we're seeing that we're always hitting the function. So every single x value is represented here. So that looks like x equals -4, 5, 6, 7. So x equals -7 to x equals +7. All x values are represented here. So our domain would be -7 to 7. Now I used the brackets here because -7 is included. If we had an open hole here instead of a closed hole, then we would use a parenthesis instead of a bracket. Okay, now we're going to go ahead and do the same thing with the range. So let me go ahead and create another line. And this time we're just going from the bottom of the graph to the top of the graph. So you can see here that we don't yet have any y values that are being hit. But as we go up, right here is the first y value we hit, and that is at -4. So that's where our range is going to start, and we're going to continue bringing this up until we stop hitting y values. So here's the last y value right here, and that is at y equals 5. Okay, so our range is going to go from -4 to 5. Again, with brackets, because at -4 and 5, those points are included because they're closed holes. All right, so we're going to go ahead and move on to our x-intercepts now. X-intercepts, that's just going to be the x values where our function crosses the x-axis. So these points right here. Now they don't cross at integer values, but that's okay. We'll just go ahead and give our best approximation. So this one looks like it's the x value is about let's see, -6, -5, -4. Okay, so about -5.5. And then this one looks like it's about -1.5, 1.5. For this guy here, and then 3, 4, 5.5. Okay, so those would be all of our x-intercepts. Now for our y-intercepts, it will just be where is our function crossing the y-axis now, and that would be at x equals 0, 2. Going back to the x-intercepts for just a second, we could go ahead and just put -5.5, 0 for -5.5, 0, -1.5, 0, etc., etc. All right, so now our symmetry. Remember, there's 3 different types of symmetry. There's just 2 types of symmetry, odd and even. To remind you, even symmetry is when we have y-axis symmetry, so symmetry across the y-axis, and odd symmetry is when we have symmetry across the origin. Here, pretend that our line of reflection is the y-axis, then we do see that we have a complete reflection across that. So indeed, in this equation, we have even symmetry. Kind of another way to check that is take any one of these points. This one here, for example, is the point 4 comma negative 4. Then the point over here should have the same y value but the opposite x value. And indeed, we do have negative 4 comma negative 4. And that holds true for every single point opposite. So like here, 1.5 comma 0, negative 1.5, 0. The y value remains the same, but the x value is flipped. Okay, so now we're going to go ahead and find f of 4. That's just asking, what is the y value when x is equal to 4? So here's x equals 4, and the y value on our function, we already figured out this is 4 comma negative 4, so the y value would be negative 4. A little bit of a different problem here. We have f of x equals negative 3. So that's asking, where is our function value equal to negative 3? Oh, and I'm sorry, I created a bad problem. A better problem would be f of x equals negative 4. My apologies. So where is our function? What x values, for what x values does our function equal negative 4? And we can see here that the y value is negative 4 here and here. So what are the x values? We've got negative 4 and 4. So there's two different values here. Okay. There's some problems that ask where is our function increasing and decreasing. So our function is increasing when the y values are increasing. So for example, here from negative 4 to 0, and we only care about the x values. And whenever we do this, we're going to use parentheses because technically at the point negative 4, it's neither increasing nor decreasing. So between negative 4 and 0, we have a positive slope, so we're increasing. And then also between 4 and 7. Just like so. Then we're decreasing on whenever we have a negative slope. So here, between negative 7 and negative 4, again, just looking at those x values. And then again, between 0 and 4. Okay, finally, if we want to find the maximum and the minimums, we're just looking for a point for the maximum where everything to the left and to the right is lower than it. So for example, here, we'd have this point. So that's the point 0, comma 2. We're not going to count these points on the end just because on the right hand side we don't have points that are lower to it. We don't know these are the only points that are included. We don't have anything to the right or to the left of those. So we won't consider that a maximum. For the minimums though, we're looking for values where everything to the left and to the right is higher than it. So namely these 2 points here. So those would be the points negative 4, and 4, comma negative 4. All right. Again, if you have any questions, please feel free to leave those in the comments below or shoot me a message through Ivy Learn.